result. In fact, it was on your quiz, or one like it, a little easier than this was on your quiz. This one's a little tricky because it's a plus, but we remember that means the distance between some number and -4 is greater than 3. So I don't know if this is the way you did it on your quiz or not, but it certainly is the fastest way. The distance between some number and -4 is 3. So this boundary out here would be -1, and this one would be -7. Since it's a greater than, we will shade out here, and our answer is everything less than -7 or greater than -1. That's old news. We talked about those in another section. This is a different kind of problem. This is a quadratic inequality. Does anybody have any idea how we would tackle a quadratic inequality? What's your gut feeling when you look at that problem? What do you just kind of want to do? Factor it. So let's factor it. Now, there are lots of ways to approach this. I think the easiest way is to draw a number line, and on that number line, put the 2 zeros of the function. Now, what would the 2 zeros of the function be?
5 and -1.
Exactly. 5 and -1. Make sure you put them on there in order. If I were going to put dots at 5 and -1, would they be open or closed? Closed. So let's do that. Now, those 2 dots have split the number line up into 3 sections. Would you agree with me? This section, and this section. Now, here's what I want you to do. I want you to pick a number in, well, you can pick one in any section, but I'll just be organized and start here. I'm going to pick a section, or pick a number in this section. What would be any number in this section of the number lines?
Oh, -3, sorry.
-3. -3 would be a number in this section of the number line. You agree? Now, if I put -3 into this parentheses, the outcome would be negative. Would you agree with that? And if I put it into this parentheses, it would also be negative? Now, this is factors, so when I multiply the negative times the negative, would I get a result that's less than 0?
No.
No, what does less than 0 mean? Negative. If you multiply a negative parentheses times a negative parentheses, that isn't going to give you what you want, right? So let's move to the next section. This section didn't work. What's a number in this section?
0.
Okay. If I put 0 in, this parentheses would be negative, but this one would be positive. So when I times them together, would I get what I wanted? So numbers in this section work. You just need to check any number. If it works, then that section's good. Now what about this section? Let's pick a number out here. 6. Putting 6 in would make this parentheses and this one positive. Now you're timesing them together. Does that give you the kind of outcome that you wanted? No. So the only section that works is this one. So my answer is the interval, the closed interval, from -1 to 5, or you could write it like this, all the numbers from -1 to 5. All right? Now, here's a cube equation, or inequality. We're going to do this on our calculator. So I want you to get your calculator out, and I want you to graph this thing. Now, we remember how to do that. We've been through it, but just to refresh our memories. Let's check our window first. I don't know what you've been graphing, but let's just use a standard window. And the standard window, remember, is x min -10, x max 10, x scale 1, and then the same thing for the y's. So if that's not your window, kind of change it. Not that it's a big, huge deal, but it just makes it easier for us to talk about it when we all have the same picture. Now, do you remember how to put that into your calculator? x, and then there is a cubed feature, but it's kind of hard to get to, so it's easiest just to do this. Raise it to the third power. And once you get the equation in, hit graph. And tell me if you see something that looks like this. Now, what is this point right here called?
Solution.
That's called a solution, or a x-intercept, or a zero. Right? Now, can we find that point? Remember how to do that? All right, so here we go. Got my graph back up. I'm going to press second calc. We talked about this, right? And then I go down to 0, because I'm looking for that 0 right there. And then I'll set my left bound and my right bound. And according to my calculator, and yours should say the same thing, the 0 is at 1.4288177. Now, what's the answer to the question? That would be the answer if this had been the problem. If the problem had been an equation, that would be the answer. But it's an inequality. Can you tell me how to get the answer, how to interpret the answer from this picture? What do you think? Trevor?
Do you have to shade a sign?
You have to shade something, exactly. And what are we looking for? Where the curve is less than 0. So where would I look? Where would I find where it's less than 0? Well, here's where it actually equals 0. So where is the value of the function less than 0? Exactly, right here. All of these points are less than 0. All of these points have y values that are less than 0. So the answer to that question is x is less than or equal to 1.43 or whatever we're going to round it off to. It's possible that when I graphed this, I could have gotten a picture that looked like this. Now this one has 3 zeros, right? So you'd have to go through that process 3 times. Then what would the answer be? If it was a less than also, what would the answer be? All of this and this right here? So I'm just going to make up numbers. If this is -4 and this is 1 and this is 6, then I would say everything less than or equal to -4, or everything in between 1 and 6. Obviously, if less than means look below the x-axis, greater than would mean look above. Does that make sense to everybody? Okay, now we need to look in our book, we need to talk about projectile motion. You will be using, for all your projectile motion problems, you will be using, by the way, projectile motion, what we mean is, you throw an object up into the air, you know, comes crashing down. If you've taken physics, you've talked about projectile motion. Look on page 63. And let's talk about the formula you're going to be using, and then we'll put it into a problem and show you how it works. Anybody have a book? Open to page 63 and see the green box up there at the top. What's it say? What's the formula for projectile motion?
S equals negative 16.
Does it say S of t or just S?
Just S.
So S equals?
Negative 16 t squared plus v, like 0 t plus s 0.
Okay. Now, let's talk about what all these letters mean. First of all, S is the letter they're using for height. Some books will use H. They're using S. This is read V sub, because that's a subscript, V sub naught. That's the way we read this. And what that represents, anytime there's a sub naught, it means the initial value of that variable. So this is the initial velocity. Would you agree that if I stood on top of the roof and threw an object up into the air, that its velocity would change over the course of its path? V sub naught is the initial velocity, the velocity at which I threw it, and then we'll learn how to find its velocity when it hits the ground and all those things. But this is the initial velocity. What is this then? The initial height. So if I am standing on the ground, the initial height is 0. If I'm standing at the top of a 50-foot cliff, the initial height is 50. If you do the problem if your distances are measured in meters, the formula is a little bit different. This is the formula for distances being in feet, heights being in feet. Okay? All right, so how does this work? Well, let's look at a problem. I'll give you a break and pick one I have assigned. Let's look at number 33. Number 33. Oh, this is on page 64. A projectile is launched straight up with an initial velocity of 256 feet per second. Tell me the formula I'm going to be using for this problem. What is my equation for this problem? What's it going to be? S equals what? Negative 16t squared. That doesn't change. Plus 256t. Plus 0. Oh, by the way, I forgot to tell you, what do you think T stands for? That's your time, yeah. So there's my equation that's applicable to this problem. Is everybody okay?
Yeah.
All right. Now, when will the projectile's height above the ground be 768?
You said that you.
So 768 goes here?
Yeah.
So 768 equals negative 16t squared plus 256t. Everybody okay? What kind of equation is that?
Quadratic.
Quadratic. Let's get it set equal to 0. Who's got a calculator? I know that one is. Is that number divisible by 16 by any chance?
Yes.
Oh, awesome. Then what we could do, we don't have to do this, but since they're all divisible by 16, that would make our numbers a lot easier to work with. So 0 equals t squared minus 16t, what did you say it was, Riley?
48.
Now, I actually divided by negative 16. Is that okay with everybody?
Yeah.
Now, you've still got a little quadratic equation. Nobody's telling you how to solve it. So what are your choices? Complete the square, quadratic formula, or factor if it factors. And I think that one factors.
3 and 19. Oh wait, no. Don't worry about that one.
I'm not gonna worry about that one. I have blocked that one out of my mind. How about negative, or t minus 12 and t minus 4?
Yeah, that's what I meant.
Now, what does that mean? That means that the object is 768 feet above the ground after 12 seconds and after 4 seconds. Wait a minute, why are there two answers?
It goes up.
Up and down, exactly. This is a quadratic equation. What does the graph of a quadratic equation look like? A parabola. And when it has a negative coefficient, it's a parabola opening down. So if you graphed this, you'd have this trusty little parabola. Here's where it's 768 on the way up and on the way down. Make sense? Oh, math is beautiful. Okay, next. When will the projectile's height be at least 768? Well, my picture's really helpful for that. This is when at 4 and at 12, this is when it is exactly 768, right? We figured that out. When will it be at least 768? In between here? So the answer would be everything between 4 and 12. This is when it is at least 768. And then what's the last one say? When will it be less than or equal to 768? Now be careful with that one.
Is this an or?
It's going to be an or for sure, because it's less than 768. Kids will say less than or equal to 4 or greater than or equal to 12. Can anybody see? That's like almost right, but there's something wrong with it. Can you see what it is, Grace?
Not equal to, right?
It could,
Oh, is that negative?
it says, yeah. Now, sometimes it would, if it just said less than, then you're exactly right. But it does say or equal to. That, there's just something not good about that answer, and we need to talk about that. Katie?
Would it be the 4?
We need an or because we're looking at times that are either here or here. Trevor?
Well, it doesn't go on forever, so it has to stop at some point.
Exactly. Tell me about all the numbers less than -4. Give me some examples of numbers less than -4, or less than 4, I mean, less than 4.
-2.
Did you just say 5?
No, I said,
Oh, okay. Pi? Oh, okay, well, that's a good pi.
it's like not a,
Yeah,
there you go.
yeah.
I say 5.
And somebody said 3, somebody said pi. What about -8? Yeah, what about -100? Yeah. Do those answers, -8 and -100, make any sense in the context of this problem? Where does time begin in this problem? At 0. So we need to say from 0 to 4, that's this section of the parabola right here, from 0 to 4. And then what? Every number after 12, like 100? No, we have to stop, don't we, right here? Oh, I don't know what that point is. Do you have an idea? Who said 16? Why 16, Trevor?
That's right.
It looks right. Okay, there's value in things just making sense and looking right, but let's have a reason for that.
16 right there.
Why does it look right, Trevor?
This is in the equation.
oh no, okay, no. I'm gonna have to shoot that one down. Just because the number's in the equation does not mean it has anything to do with the solution. Mr. Laskowski?
Well, since it's same thing, it was 768 in the first one, you found the distance from where it was ground level to 768, then you know it's 768 to 12, then you know it's the same distance.
And how do I know it's the same distance?
Slope. I'm going to say slope, I have no idea.
No, you are exactly right. This is not linear, so I really don't want to talk about slope. What is true about parabolas? They have what is called symmetry, right? When you study parabolas, you may have studied the axis of symmetry. So here's the axis of symmetry. But his point is, Mr. Laskowski's point is, look, parabolas are perfectly symmetric figures. So if it took me 4 seconds to cover this much ground, then it is going to take me 4 seconds to cover this much ground. That's why it looks right, Trevor, because you have that idea of balance and symmetry. So that is 16. So your answer is everything between 12 and 16. That's the second half. Does that make sense to everybody? Awesome. All right. Then here's what I want to do. We got 1 minute left. I would like for you, we zipped through those inequalities. I'd like you to give this one a shot. How about x squared plus 4x minus 12 less than or equal to 0? Can we solve this in a quadratic inequality? I only did one example. Can you remember how I did that? How did we do that? How did we start? Bailey? We factored it. Do you see how that one factors, Bailey?
X plus 8.
I don't think I want to use
X
8.
plus 6.
That works. That works. Anybody remember what happened next? Drew a number line and put a couple of points on here, -6 and 2, with solid dots. And then we picked
We picked a point in like one of the sections.
So it doesn't really matter, I'll just start over here. So any number in this section would be something like -8. And then I came up here to my parentheses and said, okay, I want a negative result. Does everybody understand that? Less than 0, negative result. If I put in a -8, this parentheses would be negative, and this one would be negative. They are being timesed together, right? And if they are being multiplied together, the result will not be negative. So then move on to the next section. 0, positive, negative, multiplied together. Does that work for me? 10, positive, positive, multiplied together. Does that work? No. So my answer is everything between -6 and 2. Now, both of the examples that I've done, did you notice that the sections kind of alternated in terms of working and not working? Did you notice that? Unless the problem has something funky in it, like a squared parentheses or something weird, that will always happen. So the moral of the story is, if this one didn't work, I can pretty much count on this one working and this one not working. All right, have a great day. Your homework is in P7. We'll go over today's homework tomorrow too. What is it? Okay, because you don't have now, it should have said, did it say window dimension error or something like that? Yeah. Probably the author. Oh, thank you.